Looks good.
All right, great. Well, good morning, and I do appreciate this chance to give you a few updates on some things we're doing on hopefully going to make growing cotton easier with automation and some of these new technologies. In this cover slide, I've got a couple of the weed control robots that are being used in the vegetable industry. And on the bottom left, we'll talk more about some of our prototypes on cotton harvest. Um, so in the presentation today, I wanted to start out by acknowledging at Cotton Incorporated, our ag research division. We're really lucky to work with scientists and engineers across the cotton belt. So a lot of my knowledge and information I'm going to be sharing today has come from working with a lot of talented scientists at the land-grant universities and with USDA ARS. And I don't have time to acknowledge everybody, but this is just a partial list of people that helped us to develop a paper about opportunities for automation in cotton production. And this was an open source paper we did back in 2020. And the goal of this paper is to make a lot of these startups and new businesses aware of what our needs are in the cotton industry. And this paper has been shared several times with different companies so that they can see if their automation tools fit. Another thing I have are just some pictures of other automated systems that aren't specific to agriculture. In this example, a FedEx delivery system I ran into in Memphis. So this technology is getting more ubiquitous every day. As we look at what I'll talk about today, I'm actually going to have us joined by a couple of AI podcasters. And my goal there is a lot of hype around artificial intelligence right now. And I'm going to pour a little gas on that fire and then throw some water on it after that. But one of the reasons I want to just make sure everybody is aware of where this technology is I want you to be thinking about developing a digital strategy for your farm. And so that we'll talk about that in this presentation. Then we're going to transition to the importance of machine vision. Cotton Incorporated is sponsoring a lot of projects around building some open source libraries, and I'll explain why that's important in enabling automation. And then finally, we will look a little bit at the future, and I'm not talking 30 years out. I'm talking, what is the next 5 to 10 years hold for us, and specifically kind of where we're at on our initiative to automate cotton harvest. So with that, I also want to just clarify, when I talk about automation, it's not just, high tech. Well, a lot of it is high tech, but it's some things that are probably affecting you on the farm already. Some of you, I think everyone here knows what this is, has had maybe a chance to use a module builder. And this is, one of the Cotton Incorporated and Texas A&M's contributions to industries many years ago. But I imagine most of you are using a machine like this to harvest your cotton. And what this machine did, of course, is automate that module building process, and so that it builds that module on the go. Now I'd guess about 80% of cotton is harvested in the United States using this machine. So this is an example of automation that is, probably on your turn row right now. And so that's just something I want to say that some of this is near-term practicality, not all in the far future. So I want to just introduce some AI podcasters to you right now. This was I'm going to share in a second a podcast generated by something called Notebook LM. You can see the link there. It's a tool from Google, and you can drop just PDFs into this. You'll see on the left, I dropped in a couple PDFs. These are all Cotton Incorporated generated information, so there's no copyright issues. And what it does is it creates a summary of those documents, and it allows you to interact with those by you can put in questions, and it will answer it based on those documents. And one of the things, I saw our lawyer, Andy, is on this call to keep me honest. And one of the things, with all AI tools, there are cautions you need to be aware of. For one thing, if you upload data into these tools, I would just have zero expectation of privacy and know that data that's uploaded kind of leaves your control. So keep that in mind. With something like Google LM, You want to make sure anything you upload doesn't violate copyright restrictions. And finally, with all these AI tools, right now, the level they're at, don't trust them. You need to verify. I just saw a Farm Press story that came out last week about, I don't know if it was Chat or one of the AI tools giving herbicide recommendations, and it actually gave off-label recommendations and for herbicides that would cause crop damage. So all these things you do want to verify. One thing I like about Google LM is it does make it easy to verify. If you ask it a question, it will highlight. You can have it highlight in the document you uploaded where it pulled that answer from. So with that, and so my motivation here, Google LM may be a tool that's useful to you to summarize documents. It also is, I want to just again kind of show some of the sophistication of where these tools are right now. If you haven't used it before, there's something called audio overview. So I clicked on that and asked it to give me an overview of these 4 files, one of which includes this PowerPoint presentation. And let's just take a quick listen to the beginning of this.
Welcome to the deep dive. Today we're really getting into how data, AI, and automation are changing cotton farming.
That's right. We've got some interesting material looking at the big picture and some, really specific tech.
And our goal really is to understand how these tools can give cotton growers, well, a shortcut to being more efficient and maybe more resilient too.
Exactly. We'll touch on how data is being used now, what AI might unlock, and then shift into machine vision and actual robots in the field and gin.
Okay, let's start with the data. The Agricultural Innovation blog really emphasizes this. Seems like with tough weather and costs going up, data isn't just nice to have anymore for U.S. cotton folks.
No, it's becoming pretty essential for profitability, for staying viable long term.
Yeah.
And growers are definitely adopting things.
Like what specifically?
Well, things like auto steer and GPS are huge. Something like 86% adoption. That's foundational stuff for precision ag. Plus, new harvesters. They often have cellular modems built right in.
Sending data back constantly.
Yep. Real-time yield data. It's a massive stream of information becoming available.
And that leads to actual savings, right? I saw something about irrigation efficiency.
Oh,
all right. With that, at the end, Stacy's going to send a follow-up to where if you want to hear that whole 6-minute podcast, she'll make that available for you. But I don't want to lose my job, so I'm not going to let AI take it on that one. But I hope you kind of heard that was were AI generated. Those were not real people. And all it took were these 4 PDFs I put in it. And it started creating this podcast that I found was really effective. So again, part of my motivation is to end this is if you're not capturing some of your farm data electronically right now, it's probably a good time to start. And if you've been doing that, it's going to really pay off. I'm going to do one more kind of just quick pass through on ChatGPT. That's one we hear about a lot. One caution, if you haven't used it and you Google ChatGPT, there are some spoof sites that will come up. So actually typing in that HTTP chatgpt.com will make sure you get to the right place. But anyway, I just want to real quickly go through. I started a project on ChatGPT called Cotton Data. And actually, if you're not that familiar with Chat, but played with it, there is a plus button shown here in red where you can upload data. I uploaded some data from an Excel file that's average cotton yields from 1965 to 2024 by state. And here I asked it to tell me the column headings in that file. And here's what there's not enough room to show all the columns on the screen, but here's what it's listed. And so the very first thing I asked it to do for this demo, it got wrong. All right. So this is the actual column labels that it got right after a second attempt. But I want to throw that out there to say it can confidently be wrong. So I want to, set not oversell this technology where it is. So, but then what I asked it to do, I said, okay, I've got all the cotton growing states in this file. And I said, just give me the yield in Mississippi versus year. All right. And add a trend line to it. And it got that right. All right. I went back and verified that this is indeed the trend in yield for Mississippi from 1965 to 2024. And that is the correct trend line. And it's kind of funny if you look in the top there, it says the column name for cotton yield in the file is fiber yield, not yield pounds per acre. Well, it's the one that said it's correcting its own mistake, and it acts like it's blaming it on me. So it's being a little bit snotty there. And then I went on to say, okay, so compare this against some climate factors that are in the file, and it generated this list of correlation factors. And again, my point here is not the actual analysis of yield in Mississippi, but just to show the data processing that it can do. And then it actually gave me some interpretation. It told me about the strong positive correlations and negative correlations. And then at the end, it said, hey, would you like me to build a multivariate model to, look at how these variables impact yield over time? And I said, sure. And it generated a multivariate model. And then it even went on to say one of these things that said yield increases as minimum temperature rises, somewhat counterintuitive, possible even have trouble pronouncing that one, multicollinearity. And so it generated this model. Now it's cautioning me there may be a problem with the model. And so I said, well, what is multicollinearity? And here it tells me about some of the variables are correlated. And so, and gave me some cautions. So all that is not to try to educate on how to do ChatGPT for your farm data, but is to say these tools, whether it's ChatGPT or Grok or Claude or all these tools that are out there, are going to bring new possibilities to getting more value from your data. Oh, and then finally, I do want to mention it also, Chat will generate the code that it used. And so if your kids are looking at a job as a computer programmer, the entry-level positions are going to be really hard to get because these AI tools are going to take them up. And it also allows someone that does a little bit of coding, it will generate a lot of code for you. And so it's going to speed things up from that perspective. And so all that to say, if you are not capturing data on your farm right now, I would encourage you to do so. This, and I think Stacy will include this link in a follow-up email as well, that QR code goes to, but we have a focus on cotton about developing a digital strategy for your farm. And some of this is about consistently naming fields. It's about, consistently naming products and starting to build a database for your farm. And then that will really put you in a good position as these tools get more sophisticated in turning that data into really strong recommendations that can help you, increase yields without increasing inputs. And of course, there's a lot of data coming out in cotton right now. The new harvesters, for every time it wraps a module, these are some of the data that are associated with that module: client farm field, module ID, moisture, weight, and variety are things that we did a study and looked at a lot of gin data with gin collaborators and found that variety can really impact ginning rate. So I really encourage you with your gins to share what varieties in that module. That will help them do a better job for you and make their job easier as well as the moisture. So this data has a lot of valuable uses. And this RFID technology, I'll just quickly put a plug in for this. This is, part of automation is not just the manipulators in the field or the auto driving tractors. It's about, you need to be able to automate the data as well. So if you say, you can tell a tractor go to this field and it goes to the right field, that it can automatically, when it's harvesting, automatically keep track of which module belongs to you and where it came from. So RFID is a good first step in automating data for cotton harvest. One of the things that this also now allows, if you want to do a quality map in addition to a yield map, this picture in the top right is from the University of Georgia. Wes Porter there and his student Luke Fuhrer have generated this of a field in Georgia back in 2020 when there was a lot of seed coats, and the blue lines represent the modules, where the modules came from that had seed coat calls. That green is actually a module that had a plastic call. So we can go back and look at where things happened in the field and maybe look at is there a management change that we can make to improve quality as well as yield. So this is a new technology. I encourage you to check out. That QR code will take you to kind of a resource page we have for using RFID in cotton harvest. And again, that will be a link that Stacy will share back out. So, all right, let's transition now to more of the classic automation issues. And one of the things are those machine perception systems. And I use that word perception purposely because these machines are not only, a lot of them are not only capturing images where they can use two cameras and make a point cloud. So they can actually see in 3D, and that means for a very low cost, they can generate a 3D scene that would allow, say, a robotic arm to go out and grab something. So this, and what's really interesting about this technology, a lot of the software is open source. That means there's not a charge to it. These are just, for example, ROS. Some of you that are as old as me will remember DOS, which stood for Disk Operating System. So ROS stands for Robotic Operating System. And this is a great tool, open source tool that's out there so that when people are working on automated systems, they don't have to go back and reinvent, how do I make the thing drive to a point from a GPS system or for a vision system. All those routines are already developed, so you can just start using that out the gate. Also, a lot of the computer power for this, a lot of these tools and software concepts have been around for more than 30 years, but they needed, basically a supercomputer, what we used to call a supercomputer, to do it. And now for about some of the systems that are enabling totally autonomous equipment operation on the fly, that control computer is about $400. And then again, these stereo cameras are not that expensive. They're about $450. One of the things we worked with our sustainability division to do a natural resource survey and had a few questions about automated tractors. And one thing that was loud and clear, everybody said, yeah, automation sounds great, but it better be affordable. And that is something that we are keeping in mind, that this technology not only does it need to work, it needs to be affordable. And this machine vision is really important. We've seen some of these, and we'll talk about this in the next slide on detect and spray systems. And what enables that technology is machine vision. And to do good machine vision, you need a lot of images. And this is one of the first open source weed libraries that we sponsored at Mississippi State. Galen is collaborating with the USDA Agricultural Research Service on a much bigger project where when they are in their, I think, nearing release of the first set of images over, I think it's probably going to be in the hundreds of thousands of images of weeds that can be used to train machine vision systems. And that's important because that will allow these companies to much more quickly bring you a reliable solution to your farm that will do a much better job of always finding the weed and not doing false positives. So that is something that we are investing in. And so, for example, the John Deere See and Spray is the one that's commercially available and that we've heard a lot about. But what I want to say is that's not the only one out there. As some of you are probably aware, this is a list of 25 different detect and spray systems that are out there globally. This list was compiled by Guy Coleman. He was a fellow in Australia who actually did part of a sabbatical at Texas A&M, and he is really a proponent for open source imagery that we'll talk about it here in the next slide. But anyway, you can see there's several different systems. Several of them are available in the US now, and several of them, so the ones in blue are available in the US, the ones in yellow have already been trained for cotton. And so that means these things are going to be available really, really quickly for you to test on your farm. And one of the things why these weed image libraries are important, a lot of these systems that right now are trained to detect what cotton looks like. All right. And so it's saying if it's green and it's cotton, it's okay. If it's green and it's not cotton, spray it. All right. So the next level of sophistication is getting to species level, which will become important as we look at, maybe these new systems in the future will have the ability to use different modes of action. One example of this that I think Galen is in Mississippi right now. This is a project he has at Mississippi State on a detect and till system working with Wes Lowe in the ag engineering department there. And this is a system where instead of spraying, it will put down a tillage tine you can see there. And also you see there's a spray tank. So one of the concerns, if you do till a weed, now you've disturbed the soil and if it may mess up any residual action. So it will actually also, it will till and spray at the same time to keep that residual activity present. And one of Galen's and Wes's plan is to, a lot of this is off the shelf components. And so they want to make this available so that you could take this to your local machine shop or maybe even in your own shop. I know some of you have a lot of equipment building skills and build your own detect and till system. And I mentioned Guy Coleman, there'll also be open source ways to do that detection. So for a much lower cost, you could build your own system and not have to pay service fees and things like that. So for some of you that are very technology inclined, this may be an option. And Galen's going to try to make that available towards the end of the year. Can't talk about this without throwing in some lasers. That 25 detect and spray systems were about sprays. That didn't include about 10 other laser systems out there. One of the ones active in the United States is Carbon Robotics. This is their early prototype, and I'm just going to let the video play. You can see on the right those flashes of light. The little flashes of light are actually the laser, hitting the weed. I think they've just released their third generation of this laser system, and I understand the one that went into production was kind of a tracted mounted system, and it's not going to get above about a mile per hour. So it's not really cost effective for cotton right now, but they did do some return on investments in organic vegetables in California. And found when you're competing against hoe crews that this can be a cost-effective technology. The newest version, I understand, is double the speed. Still not something we're going to use in cotton right away. But Galen is working with Glenn Rains at the University of Georgia and looking at, again, if we can detect a species and we find an escape that's herbicide resistant, maybe the system can slow down and hit it with a laser and then speed back up and go on. So, and Glenn's looking at less expensive lasers that are solid state. So there's a lot of potential here. And so that we are pursuing those types of systems. And I also want to note that it's not just weeds, this machine vision. This is an example out of Kansas State where they're detecting aphids. And so this machine vision is going to allow us, so every time, if you have these cameras on a tractor, every time it goes through the field, it can be, looking for disease and weeds and insects as well. So that I think this technology has a lot of really near-term promise. Don't want to forget about our robots in the sky. Several of you may have even tried out or had someone spray your field with these UAVs that, we of course started out using them for imagery, and now I've really been surprised. At Cotton Incorporated, we have an automation advisory committee, a subset of our board members that have agreed to help us, talk through some of these automation opportunities and what they think is worth pursuing and what's not worth pursuing. And probably we got that group together about 5 years ago, and I said, what's the thing that sounds most promising to you? And it was spot spraying. They were really interested in the ability to use a drone to go. And this is before these drones were really that common. And so we all are looking at what are the opportunities to use these autonomous application systems. I've been doing studies with Auburn on defoliation. Sally's been working with entomologists on insecticides. Caitlin's been working with pathologists on looking at how this can be used to put out fungicides. And of course, Galen's been working on this on weeds. So we're all taking a look at this technology and seeing how it can impact our respective disciplines. And a lot of it looks pretty promising. Caitlin's also leading an effort to see if we can show that maybe this is less prone to drift so we can reduce some buffer requirements, but that's yet to be determined. But there is a lot, I just want to say there's a lot of commercial systems out there right now. Most of these, again, are targeted more to the vegetable industry right now, but they are doing proof of concept that they're like this. Several of these machines are completely autonomous. This one in the bottom, the silver one in the bottom center is called Gus, and it's an orchard sprayer, and it's a partner between the company Gus that makes that and John Deere are now marketing those in California. And those things can just travel through the orchards at night without anybody driving. There's not even a driver's seat on this. So this technology is really maturing rapidly. It's being commercialized. And so we can expect it coming to the farm in the near future. So this is this is the question. Is this what the future looks like for our farms? Instead of tractors, we're going to see machines like this. This is an autonomous sprayer. It's got the See and Detect system. This is from Solitech. And they've got, I think they had about 50 of these in Brazil and 50 of these in the US last year. And I understand they have one at the University of Georgia. They're testing in cotton this year. But it has cameras. It can do See and Spray. It's solar powered, so it can continuously run in the field. They say that one of these machines can cover about 300 to 400 acres a season. And not only are they doing weed detection, but with that machine vision, they can easily track the progression of the crop and look at growth rates and things like that. So it's going to generate a lot of information every time it goes across the field. So is that our future? And, when I talked with the automation committee, some were concerned. If you look on the far left, that was an early prototype on cotton harvest from Clemson University. And one of my advisory members said, I don't want 50 of those things on my farm. And I can understand that. You can imagine that might end up creating more labor if it's not well designed and very self-supporting. So maybe, it's going to be something in the middle, or maybe it's one of these machines like we saw from Solitech, or, it's going to do maybe 4 to 8 to 12 rows at a time. But again, it's autonomous. We're already seeing this model from Swarm Farm in Australia. I know they've brought over some machines to the US. And they're also getting where they can do autofill, so they can refill themselves. So they're becoming more truly autonomous, where you don't have to be out there to refill the herbicide or refill the fuel tank. And of course, John Deere, Case, AGCO, they all have versions of driverless tractors now where it goes beyond auto steer. And I'll be honest, just from my perspective as an engineer, I'll be really disappointed if our autonomy stops with just making tractors drive themselves. I really hope this leads to some new innovation on the farm. And along with that, we are looking at, could automation, if you don't have to have a driver, if we can get this where it's truly autonomous for cotton, could we actually allow multiple passes during the season? And this might be a little bit of a pipe dream, to have 25 passes, but could we do multiple passes so that when your cotton starts opening in September, those bottom bolls are out there for, 50 days before they're harvested. Can we make a pass and get some of that cotton in before the hurricane comes, before the hailstorm comes? And also, we find every time cotton gets rained on, that immediately hurts its color. So we could improve quality, less soil compaction. And also the vision is that like that Sullivan tech that is spraying your weeds during the season, and then we change it out, and maybe it could harvest your cotton in the fall. So those are some things we're looking at. When you look at a lot of the university prototypes that we're testing, they're going to be small because that's the most cost effective and safest way to do research on these things. But just know that any of these machines, even if it's just a one row unit, the control system, the concepts can easily be scaled to a multiple row system. On the bottom left, you can see Joe Maha's now at the University of South Carolina. He's been working on it's almost like an autonomous row unit at Mississippi State. They're looking at single bowl harvest, not really with the idea that may be feasible, but more with the idea that we're going to learn how to better design an automated harvester if we could do single bowl. And then University of Georgia has a really interesting concept of where they could harvest, like say, a fifth to a third of the plant at a time where they don't have to worry about single bowls. So that one looks really promising. So we are looking at different ways to be innovative with harvest. Also, gin, we're looking at the gin. The gin industry, has already made a lot of progress. Those of you that are familiar with ginning, you used to go into a lot of gins at the bell press, and there'd be, 8 to 10 people running around. And now with automated strapping and bagging and sampling, there might just be one person just watching the system. Again, I think the automated data flow with RFID is going to has the potential to help the gin. And then there's a lot of data that goes through that gin. And we've been looking again at what opportunities are there to better use that data to improve control and throughput through the gin. And finally, module handling, and this could be applied to the farm too, but the gin yard, there's already a company called Vermeer that does a lot of hay handling equipment. They have a prototype handler for round hay bales that can already automatically stage those in the field. So that's really not that far in the future. So there's a lot of things coming at us. I don't want to oversell this too much. There's going to be some challenges. I know a lot of, obviously a lot of you in rural areas, so getting technical support in those areas can be challenging. So these systems are going to have to be really robust. In some industries, there's concern about worker displacement. I think in our agriculture and our cotton industry, I don't think we're as concerned about that because you don't have the workers to start with, and that's why the automation is needed. But we are kind of keeping that in mind, especially at a gin where if you automate it so much, everything's great when everything works. But when if a choke does happen, you do still need some hands to help clean up that mess. So that's something we're keeping in mind. Definitely cost. I know no one wants extra costs, so we're trying to really keep that in mind. We don't want this to increase your management time. We want it to decrease management time. We got to think about transporting between fields, vandalism and theft, and then also power. I think solar is looking really promising. That machine in the bottom right is from Australia, and it's a couple years ago. It could run 20 hours just on the solar charge it got during the day, so it didn't make it all the way through the night. But that reminds me that Galen asked me to put a caution out there that, to not overthink that these machines can run 24/7, especially applying herbicides, that some herbicides really need to be applied in daylight so that they get taken up by the plant. So with that, I would say, I think, there's a lot of technology that's going to help us improve production efficiency. Machine vision is really going to have a great impact on us. I think in the future, we're going to see smaller autonomous equipment. And there's that QR code, and I'll give that to Stacy as well to share later. But anyway, went a little longer than I meant to, but I'll stop at that point and be glad to answer any questions.